Alright, in the last video we made a very big connection between using our properties of algebra to help us in simplifying things that have trigonometric expressions in them. So our next task is going to be to try to simplify trig expressions that are given to us. So again, we're not solving equations, we are just looking to simplify, and to do that we're going to be using our identities to substitute those in and using some algebra. Really, there's no right or wrong way to do this as long as you're always substituting with identities that are true and you are making those legal math moves. Something that will help you is if you take the time and memorize your identities. Yes, you will get to use your sheet on a test or a quiz, but the less often you have to refer back to that sheet, the faster these problems will go and the less stressful they will be. So, let's get started. Simplify the trig expressions. Our goal with simplifying, most of the time, is going to be to try to write less than what we started with. So right here we have two functions, tangent of x and cosecant of x. So we'll look at this example first. Right now I'm writing two different things. So I'm going to use some identities and see if I can't get anything to cancel and simplify. Thinking about tangent of x, I'm going to make the substitution that tangent of x is sine over cosine. For cosecant of x, I'm going to make the substitution that cosecant is 1 over sine. Now, you might ask yourself, how does she know that those are the ones you should pick? It just takes practice. The more of these that you do, the more likely you will be to see a good identity to use the first time around. So now, our signs are going to cancel, and we're going to be left with 1 over the cosine of x, which you may recall is equal to the secant of x. And we're done. Writing secant of x is simpler than writing tangent of x times cosecant of x. Alright, the next one, 1 minus cosine squared times cosecant. Oftentimes when you see a 1 combined with a trig function squared, you're going to want to think about your Pythagorean identities. So, our important Pythagorean identity that we started with to find the others was sine squared plus cosine squared equals 1. Well, that means that sine squared will be equal to 1 minus cosine squared, because all I did was kick this cosine to the other side of the equation. Using this identity then, I can replace 1 minus cosine squared with a sine squared of x. Cosecant, I'm going to use its reciprocal identity, 1 over sine. So really I have sine squared over sine of x. And if you remember from our algebra connection, that's like having x squared over x. So one of these is going to cancel, and I'll be left with just x. So for us, one of our sines is going to cancel, and I will be left with just the sine of x. Sine of x is simpler than writing 1 minus cosine squared times cosecant. Alright, moving right along. Anytime you see these pi over 2 minus and pi over 2 minus, you want to think about your co-functions. So sine of pi over 2 minus x is actually the same thing as cosine of that angle. Likewise, cosine of pi over 2 minus x is equal to sine of that angle. If you look on your identity sheet, this is under the co-functions. Okay? So cosine over sine simplifies to cotangent of x. And we're done. Writing cotangent of x is much simpler than writing all of this. If you have not taken out your identities sheet yet, you might want to be doing that because a lot of these things that I'm going to be referencing are right on your sheet and you should be able to find them and verify that I'm doing my math correctly. Alright, simplify the trigonometric expression. Over here, we've got sine gerene over cosine gerene will equal tan gerene. Get it? Fruit. Okay, back to the math. Simplify the trigonometric expression. So again, you might want to be asking, how do I know what things to substitute for? If you're stuck and you can't see it right away, a good suggestion is to change to sines and cosines. It's not always the most efficient because you end up writing a lot more than you need to, but oftentimes it's a good place to start, especially until you get the hang of these. So 1 over sine, tangent will turn into sine over cosine, and secant's going to turn into 1 over cosine. Sine and sine are going to cancel with algebra. So I get 1 over cosine plus 1 over cosine. Well, 1 over cosine is the same thing as secant. Likewise, 1 over cosine is the same as secant. And secant plus secant will equal 2 secants. 2 secants is much simpler than writing all of this. Alright, simplify the trig expression. I'm going to have you think about this one on your own. See if you can take the time to substitute in some identities. I suggest sines and cosines for this one. Then I'm going to have you pause the video and try it on your own. Come back when you're done and see if we match. Did you get an answer of 1? Hopefully so. I left sine where it was. I turned secant into 1 over cosine. And I turned cotangent into cosine over sine. My cosines canceled, my sine and my sine canceled, and I was left with just 1. 1 is much simpler than writing all of this. If you picked an angle and you multiplied its sine value times its secant value times its cotangent value, it will always simplify to 1. It would not matter what angle you pick for theta. That will always be true. Alright, this one, let's do together. We'll talk through. So, secant of b, I'm going to leave that one alone for right now because that's not too complex. I'm going to work with the sine and tangent that's happening. So this will be sine of beta times sine of beta over cosine of beta. So this whole thing is sine squared over cosine. Alright, well now thinking about secant of beta, if I do substitute in, that's going to give me 1 over cosine of beta. This is not getting any simpler, or at least it doesn't look to be. But what do you notice about 1 over cosine and sine squared over cosine? If I want to subtract those things, they need to have common denominators, and they do. So I can write this as 1 minus, don't know why that's happening, 1 minus sine squared of beta, my negative sign is jumping all over the place, all over cosine of beta. I don't know why this is going on. Okay, we're back. 1 minus sine squared all over cosine. Well, just like we did on the first example, sine squared plus cosine squared equals 1. That means cosine squared equals 1 minus sine squared. So I can replace all of this with a cosine squared, all divided by cosine. One of my cosines is going to drop, and I'll be left with just the cosine of beta. Final answer. Alright, this next one is a challenge, and I'm going to leave it to you if you want to. I'm going to jump to the next slide and do our summary, and then I'll go back to this one and post the answer if you decide that you want to try this and see what you get. Protect yourself from identity theft. Don't use the wrong identities. Make sure you're always making legal math moves. So, in summary, substitute identities. This can mean a lot of things. Alright? You can use Pythagorean identities, cofunction identities, quotient identities, a lot of them. Next, you want to try to distribute anything in to simplify. You could combine fractions by adding or subtracting if they have common denominators. You might need to find a common denominator, which would be perfectly alright. When I say multiply by quote-unquote 1, I mean multiply by something that is 1. So if you multiply by sine of theta over sine of theta, that's 1, right? It's disguised, it's dressed up for Halloween. So multiply by some form of 1. You can split up your fractions. We had the example from our algebra one. X minus y over y, you could split that up into x over x minus y over x. Likewise with trigonometry. A lot of times when you see squares, especially squares that are with a 1, you're going to use something with Pythagorean identities, whether it's the ones with tangents and secants, cosecants and cotangents, or sines and cosines. As kind of a last result, I would say change to sine and cosine. Now most of the ones we did today, I changed to sine and cosine, but that's because we were working with the basic ones. When they get messier, writing complex fractions and double fractions with sines and cosines, it gets to be really messy really fast. So I would just be careful with when you choose to do that. So at this point, if you don't want to try the challenge, although I suggest trying the challenge, you can be done. Otherwise, go ahead and pause the video, and when you press play, I will have the answers all set to go for you. So go ahead and pause now. Alright, if you stuck it out for the challenge, I distributed cosecant into this first term, right here, and I distributed it to the second term, right here. Then I went through, changed things to sines and cosines, just because I kind of got stuck, didn't know what else to do. A sine and a sine cancel. One of my cosines will cancel, so I'm left with cosine squared. Sine and sine cancel, I get a minus 1. So then this cosine squared and a minus 1, like I said, when you see a square combined with a 1, it helps to think about your identities and see if you can kind of switch them around within Pythagoras to make your answer what you want it to be. So here's my original identity. I moved the 1 to this side to get my cosine squared minus 1. But then to get that by itself, I kicked the sine squared to the other side and ended up with negative sine squared of x. Simplifying trig expressions. Next time we're going to start proving them. Get excited.